worksheet contained only one question. It was 2015 paper 1 section B question 7. So it was a 40-mark question. So let's take a look. So this is a mix of really algebra and working a little bit with Pythagoras. So sits kind of within the geometry trigonometry side. And there's a little bit as well with regards using Pythagoras. So really a geometry side in one part of the question, but it is predominantly an algebra question. So it says there are three natural numbers, a, b, and c, such that a squared plus b squared equals c squared are called Pythagorean triples. So we're used to this. That basically means it is a right angle triangle. So we have three numbers here that satisfy the fact they are a right angle triangle, where c is the longest side, the hypotenuse. When we can show this, they're called a Pythagorean triple. And we've seen that in other questions as well. So it said let a equal 2n plus 1, b equal 2n squared plus 2n, and c equal 2n squared plus 2n plus 1. Pick one natural number n and verify that the corresponding values of a, b, and c form a Pythagorean triple. Okay, so we need to pick first a natural number. So the easiest thing we can do is let n equal 1. That's the easiest natural number. Now, it doesn't matter what natural number you pick to use, but obviously we want to make our lives as easy as possible, and we'll do that by having the easiest number to work with. So the first number is a, which is 2n plus 1. So subbing in our 1, we get 2 times 1 plus 1, which gives us 3. Our b then is 2n squared plus 2n, which subbing in our values gives us 1 squared plus 2 times 1, that gives us 4. And then for c, we have 2n squared plus 2n plus 1. So that is 1 squared plus 2 times 1 plus 1, and that gives us 5. So we want to prove or verify. So they want to verify a squared plus b squared equals c squared. So let's take a look. So a is 3, so if I square that, plus 4 squared equals 5 squared. Now you might recognize that's actually one of our special triangles, so it is true, but let's work it through. 9 plus 16 equals 25. 25 equals 25. So that is true. So we'll just finish it off. Therefore, for n equals 1, which is the natural number we pick, a, b, and c form a Pythagorean triple. Great, so very straightforward. So they've now asked to prove that a, b, and c will always form a Pythagorean triple. So that's where n is an element of the natural numbers. So basically what we did in the last time is we picked a natural number and it worked. However, we can't say for sure that it would always work without testing all the natural numbers. The way we can work to make sure all the natural numbers work is work with them in the form that they have. So we have here, I'll just highlight each piece so we can see it. We have A, we have B, and we have C. So we want to prove that a squared plus b squared equals c squared. So let's work with that. So a squared. So a is 2n plus 1, that's squared, plus b squared, 2n squared, plus 2n all to be squared is equal to 2n squared plus 2n plus 1 all to be squared. Now, there's a lot to do here. I suppose the left hand side is not so complicated if you're using the shortcut for squaring. The right hand side, we don't have a shortcut to square a bracket containing 3 terms, so we're going to have to multiply those 2 brackets out. So what I'm going to do, just to make my life a little bit easier, is I'm going to label this the left hand side, and I'm going to label this one the right hand side, and I'm going to work with them separately. So let's work with the left hand side first, and then I'll pull them back together at the end. So left hand side is 2n plus 1 squared plus 2n squared plus 2n all to be squared. So shortcut is square the first, 4n squared, plus twice first by the second, plus 4n plus square the last. Same thing here, square the first plus 4n to the power of 4. So when we're squaring n squared, we get power of 4, plus twice the first by the second, so we get 8n cubed, plus square the last, 4n squared. Now, we need to see, is there any kind of cleanup that we can do? And there is, because we have this 4n squared here and a 4n squared here. Other than that, we have no cleanup, so let's write it out. So we get 4n to the power of 4 plus 8n to the power of 3 plus 8n squared plus 4n plus 1. So now moving on to the right hand side, we want to square out that bracket. So we get 2n squared plus 2n plus 1 all to be squared. So we're going to write the bracket out twice. 2n squared plus 2n plus 1 by 2n squared plus 2n plus 1. Separating that out, we get 2n squared by the second bracket, 2n squared plus 2n plus 1, plus 2n by the bracket, 2n squared plus 2n plus 1, and finally plus 1, 2n squared plus 2n plus 1. So multiplying that out, we get 4n to the power of 4 plus 4n cubed plus 2n squared plus 4n cubed plus 4n squared plus 2n plus 2n squared plus 2n plus 1. Now, just to see where our like terms are. So here's a power of 3 and another power of 3. Here's a 2n squared. Here's a 2n squared and 2n squared. And here's a plus 2n and a plus 2n. So rewriting this, we get 4n to the power of 4 plus 8n to the power of 3 plus 2 and 4 and 2, we get 8n squared plus 4n plus 1. So bringing back the left hand side equals the right hand side. So we have 4n to the power of 4 plus 8n to the power of 3 plus 8n squared plus 4n plus 1, and that equals 4n to the power of 4 plus 8n to the power of 3 plus 8n squared plus 4n plus 1. Okay, so therefore a squared plus b squared does equal c squared. A, b, and c form Pythagorean triple for all n elements of n. So we've proven it there. So often when you have like a long multiplication like that, and if you look at that right hand side, it does get quite long. If you were trying to do that within the initial equation, it can get quite long and difficult. So do split it out if you can to make your life much easier. So part B, ADEC is a rectangle where AC is 7 meters, and we can see from the diagram that AC is split there into AB and BC. So AB is 5, BC is 2, so that's where the 7 is. And AD, so the width of that rectangle, is 2 meters as shown. B is a point on AC such that AB is 5 meters, and P is a point on DE such that the length of DP is X meters. Now, what's a really good idea to do in questions across the board is to, as you're reading through it, link it back to the diagram you've been given and see, well, is all the information given in the paragraph given on the diagram? Sometimes you might find there is an extra piece of information that's not given on the diagram, and sometimes you might just find everything given in the paragraph is represented on the diagram. But don't assume that just because they've given you a diagram, the diagram is complete. Okay, so they want us to find this function f of x, which is equal to the length of PA squared plus the length of PB squared plus the length of PC squared. So if we take a look at those lengths, so the first length I'm going to do is PA. So the point goes from P to A. So we have this line in here. Try again. Okay. Now, we also have the line PB. And we have the line PC. Okay, so notice that for PA and PC, we have two right angled triangles. So I'm just going to go over. So here we have a right angled triangle in red, and I have the same over here, right angled triangle. So for both of them, we can use Pythagoras. Remember, the start of this question was Pythagoras, so that makes sense. So PA squared, because PA is the hypotenuse, is equal to x squared plus 2 squared. So cleaning that up, it's x squared plus 4. I'm jumping straight to PC squared, and that's going to be equal to, right, well, you need to look here. So CE, because it's a rectangle, it's going to be 2 meters. It's going to reflect the other side. And PE. Now, the length of PE, we know that DE is 7. They've already used x, so this is 7 minus x meters. The whole thing from D to E is 7 because it's a rectangle, and from D to P is x, so what's left here is 7 minus x. So this is 7 minus x squared plus 2 squared. Let's multiply that out. Square the first, twice the first by the second, square the last, plus 4. This can be cleaned up. Excuse me, x squared minus 14x plus 53. So the last piece that we need is PB squared. Now, where we have PB, it doesn't create a right angled triangle straight away. So for example, PBCE is quadrilateral. So we've been using Pythagoras, and notice that they again have PB squared. So there must be a right angle triangle we can create, which will help us. So what we can do is drop a perpendicular line from P up to meet this line. Okay. So I'm going to put a point here. I'll do it just slightly darker. And I'm going to call this F. Okay, so I've created a right angle triangle. Now, this is a rectangle, it's perpendicular, so this must be 2 meters. That's fine. But what about the length from F to B? Well, A to F is equal to x meters, because we basically just created a rectangle where AF is the same as DP. We know AB is 5 meters, so therefore FB is 5 minus x. So that's that piece up here. Let's start. So you can link back. So using Pythagoras again, this is equal to 2 squared plus 5 minus x squared. That gives us 4 plus square the first, 25, twice the first by the second, minus 10x, square the last, plus x squared, which gives us x squared. plus 29. So going back to the initial function, f of x, and they told us that was equal to PA squared plus PB squared plus PC squared. So that's x squared plus 4 plus x squared minus 10x plus 29 plus x squared minus 14x plus 53. Now we want to add our like terms. We have an x squared term here. We have an x squared term here. And we have an x squared term here. We have an x term here. And an x term here. And we have 3 constant terms here. So that gives us 3x squared minus 24x plus 86, which is exactly what they wanted. So we have our QED. So the last part of this question says the function f of x has a minimum value at x is equal to k. Find the value of k and then the minimum value of f of x. So let's take a look. The function itself we've been given on the previous part. So that is f of x is equal to 3x squared minus 24x plus 86. So this is actually a differentiation question. Once we see a minimum value of a function, we need to be thinking differentiation. So the first thing we're going to do is we're going to find the derivative of f of x, which is f dash of x, and we get 6x minus 24. Okay, so to find the minimum value, we let f dash of x equal to 0, and we solve for x. Okay, so we have 6x minus 24 equals 0. So 6x equals 24. So x equals 4. So therefore k equals 4. So now, that's not it, because they didn't just say find the value of k, they also asked for the minimum value of f of x. So we have f of 4, we want to find that. So we have 3 4 squared minus 24x. Sorry, I should be subbing in 4 here. So 24 by 4 plus 86. 3 times 16 minus 96 plus 86. 48 minus 96 plus 86. And clean that up, we get 38. So this here is the min value of f of x. It's the minimum value of that function. So you can see where they can slot in a little bit of differentiation and just at the end of a little function question, an algebra function question, and it's not terribly difficult. However, sometimes people don't realize that it can happen like that. So please be aware of anytime we're seeing minimum or maximum value of a function, we should be thinking differentiation.